The Sherman tank, designated Devil Dog, threw its right track at 15:14 hours on July 11, 1944, exactly 140 meters from the German line outside St. Lo, and Sergeant Thomas "Tommy" Rourke knew his crew had about 90 seconds before they died. The tank had been advancing across a wheat field that morning when the transmission made a sound no Sherman commander ever wanted to hear. A grinding metallic shriek followed by a violent lurch as the entire final drive assembly seized solid. The 33-ton vehicle slewed hard right, throwing everyone inside against the hull, and then stopped dead with its broadside exposed to the German anti-tank guns dug into the hedgerow 150 yards away. Rourke's driver, a 19-year-old kid from Oklahoma named Billy Weathers, was screaming into the intercom that the controls were frozen, the steering levers wouldn't budge, nothing was responding. The gunner, Corporal Hayes, was already traversing the turret toward the hedgerow because he understood what was about to happen. They were a stationary target in open ground, and somewhere in those trees was a Panzer IV, or maybe a Panther with an 88mm gun that could punch through their frontal armor like tissue paper. The first German round missed by 6 feet, throwing up a column of dirt that rained down on Devil Dog's engine deck with a sound like hail on a tin roof. Rourke didn't need to look to know it was ranging fire. The German gunner was walking his shots in, and the next one would be dead center. He grabbed the radio handset and started screaming for smoke, for covering fire, for anything that could buy them enough time to bail out before the ammunition stowed in the hull turned their tank into a blast furnace. But even as he shouted into the radio, Rourke's mind was racing through the mechanical failure he had just experienced, and something about it felt wrong, felt familiar, felt like a pattern he had seen before. This was the third Sherman in his company to throw a track or seize a final drive in the last 48 hours. 3 tanks immobilized not by German fire, but by their own drivetrains failing at the worst possible moments. The odds of that being coincidence were 0. 20 meters behind Devil Dog, Corporal Jack Hendricks was watching the disaster unfold from the commander's hatch of his own Sherman, and he knew exactly what was killing these tanks, because he had spent the previous night elbow-deep in transmission grease trying to figure it out. Hendricks was not supposed to be a tank commander. His actual job was assistant maintenance supervisor for Baker Company's 2nd Armored Division, which meant he was responsible for keeping 14 Shermans running in combat conditions with inadequate parts, insufficient tools, and a supply system that treated mechanics like an afterthought. He was 28 years old, a former Chrysler assembly line worker from Detroit, who had been drafted in 1942 and discovered that the Army desperately needed people who understood how machines worked. He had never wanted to be in a tank. He wanted to be in a repair depot somewhere safe. But Baker Company had lost so many commanders in the fighting since D-Day that anyone with mechanical knowledge was being pressed into combat roles. The previous evening, July 10th, Hendricks had been supervising the recovery of a disabled Sherman that had broken down during an advance near Pont-Hébert when he noticed something that made his stomach drop. The tank's final drive housing, the critical gearbox that transferred power from the transmission to the tracks, had been torn open by the crew in a desperate attempt to fix whatever had failed. Inside, Hendricks found complete destruction. The bull gear, the massive 36-tooth gear that drove the sprocket, had sheared off 6 teeth and welded itself to the pinion gear through friction heat. Metal shavings filled the housing like glitter. The differential was cracked. The entire assembly was garbage. But what caught Hendricks's attention was what wasn't there. The thrust washer, a simple flat ring of hardened steel that sat between the bull gear and the housing to absorb axial loads, was missing completely. Not broken, not worn, but entirely absent, as if it had never been installed. Hendricks had built transmissions at Chrysler for 6 years before the war. He knew that without a thrust washer, the bull gear would gradually walk forward under load until it contacted the housing face, creating friction, generating heat, and eventually catastrophic failure. It was basic automotive engineering, the kind of thing that would get you fired from an assembly line. He assumed this was a one-off manufacturing defect. Maybe some worker at the Lima Locomotive Works had forgotten to install the washer. Maybe quality control had missed it. But then he started checking other tanks. Of the 14 Shermans in Baker Company, He could access the final drives on 8 of them without major disassembly. He found thrust washers missing or severely worn in 6. 6 out of 8. That wasn't random. That was systemic. Hendricks reported his finding to Captain Morrison, the company commander, who listened with the exhausted patience of a man who had more pressing problems than transmission theory. Morrison had lost 23 men in the last week. 2 of his tank commanders had been killed by German 88s. His unit was understrength, undersupplied, and about to assault a heavily defended position outside St. Lo as part of Operation Cobra. He needed functioning tanks, not mechanical dissertations. "Can you fix it?" Morrison asked. Hendricks explained that fixing it properly required pulling each final drive, disassembling it, installing new thrust washers, reassembling with proper shims and torque specs, which would take 4 to 6 hours per tank with a full maintenance crew. They didn't have 4 hours. They didn't have new parts. Morrison looked at him for a long moment, then said the words that would change everything. "Then fix it improperly. I need these tanks running tomorrow morning." That night, July 10th, while the rest of Baker Company tried to sleep in foxholes and under ponchos, Hendricks sat in the maintenance half-track with a Coleman lantern and started working the problem. The thrust washer specifications for an M4 Sherman final drive were straightforward enough. Inner diameter 3.875 inches, outer diameter 5.25 inches, thickness 0.125 inches, hardened steel, ideally heat-treated to Rockwell C4550 for wear resistance. The Army supply system could probably get him proper washers in 3 to 4 weeks if he filed the right paperwork. He needed them in 8 hours. Hendricks started walking through the destroyed vehicle graveyard that had accumulated behind the American lines, a collection of burned-out Shermans, disabled half-tracks, and knocked-out German vehicles that mechanics scavenged for parts. Most of the German tanks were useless for American needs, different specifications, different metallurgy, but Hendricks wasn't looking for German parts. He was looking for American washers that might be close enough. He found them in the track adjustment assemblies. Sherman tracks used large flat washers, approximately 4 inches in diameter, to space the track adjustment bolts. They weren't the right size, weren't the right thickness, and weren't heat-treated, but they were hardened steel and they were available. Hendricks collected 28 of them from various wrecks, carried them back to his half-track, and spent the next 3 hours with a grinding wheel, a file, and a caliper reducing each washer to the approximate dimensions needed. The grinding wheel was meant for sharpening tools, not precision machining, and Hendricks had no lathe, no mill, no proper equipment. He was eyeballing tolerances that were supposed to be held to thousandths of an inch. By 0300 hours, he had 16 washers that were close enough, maybe, to function as thrust washers if they didn't shatter under load or wear out in the first hour of operation. The modification procedure Hendricks developed was brutal in its simplicity. He couldn't pull the final drives properly, didn't have time or equipment, so he improvised. First, remove the sprocket retaining bolts and slide the entire drive sprocket off its shaft, which normally required a puller but could be done with a sledgehammer and profanity if you hit it right. Second, reach into the gap and fish out whatever remained of the original thrust washer if anything was there. Third, coat the new improvised washer with heavy grease to help it seat properly and slide it into position. Fourth, hammer the sprocket back on and torque the retaining bolts to spec, approximately 250 foot-pounds, which Hendricks measured by feel because his torque wrench had broken 2 days earlier. Total time per tank, 12 to 18 minutes if nothing went wrong. Hendricks tested the modification on his own tank at 0430 hours on July 11th, fired up the engine, engaged the transmission, and drove it 200 yards in a circle while monitoring for abnormal vibration or noise. The drivetrain felt solid, felt normal, felt like it might actually work. By 0800 hours, Hendricks had modified 7 of Baker Company's Shermans, installing his makeshift thrust washers in every final drive he could access. He didn't tell anyone what he had done except Captain Morrison, who asked only one question. "Will they run?" Hendricks answered honestly. "For a while." That was good enough. At 1200 hours, Baker Company received orders to advance toward St. Lo as part of a coordinated push to break through German lines. The attack went badly from the start. German resistance was heavier than expected. The hedgerows provided perfect defensive positions, and American tanks found themselves channeled into kill zones where Panzer IVs and dug-in anti-tank guns could engage at ranges under 200 yards. By 1500 hours, Baker Company had lost 2 tanks to enemy fire and 1, Devil Dog, to mechanical failure. Sergeant Rourke's tank was sitting immobilized in the wheat field, and Hendricks was watching from 20 meters away, knowing that his modification hadn't reached that particular Sherman. The second German round hit Devil Dog's turret at 1515 hours, a glancing blow that ricocheted off the armor and took the radio antenna with it, but also meant the German gunner had found his range. The third round would be through the hull. Rourke knew it. His crew knew it. They were already popping hatches, preparing to abandon the tank, when Hendricks made a decision that was probably suicidal but felt inevitable. He keyed his radio and told his driver, a quiet kid from Nebraska named Miller, to drive straight at Devil Dog and position their tank between the disabled Sherman and the German line. Miller didn't hesitate, just pushed the throttles forward, and Hendricks's Sherman surged ahead, 33 tons of steel and fury, to block the next German shot with its own hull. It was the kind of move that gets you court-martialed or decorated, depending on whether it works. Hendricks's tank slewed into position at 1516 hours, presenting its frontal armor to the German guns, while Rourke's crew bailed out and ran for cover in a drainage ditch 30 yards away. The German gunner in the hedgerow, probably confused by the sudden appearance of a second target, held fire for maybe 10 seconds while deciding which tank to shoot. Those 10 seconds were enough for Hendricks to realize something critical. If he retreated now, the Germans would destroy Devil Dog and use its burning hulk as a landmark for targeting other American armor. If he held position, he was a stationary target, and stationary tanks died. But if he could somehow get Devil Dog mobile again, if he could fix that seized final drive right here under fire, they could tow it back to American lines. It was insane. It was impossible. And Hendricks was already climbing out of his hatch. "Miller, give me smoke," Hendricks shouted into the radio as he dropped to the ground. His gunner triggered the hull-mounted smoke dischargers, and white phosphorus bloomed across the field, thick chemical fog that burned the throat and obscured vision. German machine gun fire started raking through the smoke immediately, tracers like angry hornets, but Hendricks was already running the 20 meters to Devil Dog in a crouched sprint. He reached the disabled tank, threw himself under the right-side sponson, and started working while bullets sparked off the armor above his head. The seized final drive was obvious. The right track was completely jammed, and Hendricks didn't need to disassemble anything to know what had failed. No thrust washer. The bull gear had walked forward into the housing and welded itself solid. There was no way to fix it properly, but Hendricks didn't need proper. He needed functional for about 400 meters. He had one improvised thrust washer left in his tool bag, a salvaged track spacer he had ground down that morning. The German fire was getting heavier. The smoke was starting to clear, and Hendricks could hear Captain Morrison on the radio screaming at him to get clear before the next 88mm round turned him into paste. Instead, Hendricks pulled a pry bar from his belt and started hammering it between the sprocket and the housing, trying to create enough gap to force the bull gear backward off the housing face. The pry bar bent. He grabbed a bigger one. The second German round hit Devil Dog's turret at 1518 hours, a solid hit this time that punched through the commander's cupola and detonated inside, turning the interior into a blast furnace. But Hendricks was underneath and survived the explosion that rained burning debris down around him. The blast actually helped. The shock of the explosion had jarred the seized final drive loose, and when Hendricks looked up through the smoke and flames, he could see the bull gear had shifted backward maybe 1/8 of an inch. He shoved his washer into the gap, packed it with grease, and used the pry bar to lever the sprocket back into position. The entire repair took maybe 90 seconds and had approximately zero chance of lasting more than a few hundred yards. But that was all they needed. Hendricks combat rolled out from under the burning tank, sprinted back to his own Sherman through fire that tore up the ground at his feet, and keyed the radio. "Devil Dog's track is freed. Someone get a tow cable on it before it cooks off." Recovery under fire is one of those operations that exists more in theory than practice because most crews aren't crazy enough to try it. But Baker Company had already lost 6 tanks that week and wasn't about to lose another. 2 Shermans, including Hendricks's, maneuvered into position while German anti-tank fire bracketed them, hooked tow cables to Devil Dog's towing lugs, and dragged the burning hulk backward across 140 meters of open ground, while ammunition cooked off inside and machine gun fire hammered their armor. They made it back to American lines at 15:24 hours, 10 minutes after the initial breakdown, and Devil Dog burned for another 30 minutes before someone got a fire extinguisher on it. The crew survived. The tank was a write-off, and Hendricks sat in the grass behind his Sherman, hands shaking from adrenaline, realizing that he had just proved something terrifying. His improvised thrust washers worked well enough to prevent catastrophic failure, which meant the mechanical problems killing American tanks weren't acts of God or bad luck. They were preventable. Every Sherman in Baker Company, every Sherman in 2nd Armored, probably every Sherman in the entire European theater had the same flaw, the same missing or inadequate thrust washers that would eventually cause final drive failure at the worst possible moment. And somewhere, someone in the Army's logistics chain had decided that thrust washers weren't important enough to manufacture properly or ship adequately, which meant American tank crews were dying because of an 8-cent part that a Detroit mechanic could improvise from scrap metal. That night, July 11th, while the rest of Baker Company consolidated their positions and mourned their dead, Hendricks modified 6 more Shermans. By dawn on July 12th, every operational tank in the company had his improvised washers installed. Captain Morrison never asked for details, just watched Hendricks work and made sure nobody from battalion headquarters interfered. At 0600 hours on July 12th, Baker Company received orders for the main assault on St. Lo as part of Operation Cobra, and for the first time since landing in Normandy, they went into battle with a full complement of mechanically sound tanks. What happened over the next 6 hours would make Hendricks's name legendary among armor mechanics, though the story would remain classified for 40 years because the Army didn't want anyone asking why thrust washers had been inadequate in the first place. But on that morning, as American armor rolled forward into the deadliest battle of the Normandy campaign, Corporal Jack Hendricks sat in his commander's hatch and watched his improvised modifications go to war. And somewhere in the German lines, 73 Panzer tanks were waiting. The German counterattack hit Baker Company at 0847 hours on July the 12th, 1944, and it came with a precision that suggested the Wehrmacht had been planning it for days. 16 Panzer IV tanks and 8 Panther tanks emerged from concealed positions in the bocage hedgerows south of St. Lo, their long-barreled guns already tracking targets as they advanced across a 600-yard front. The Americans had expected resistance, but not this. Not 2 full companies of German armor appearing simultaneously in what intelligence had described as a lightly defended sector. Captain Morrison's voice crackled over the radio net with forced calm, calling out targets and positions while his own Sherman fired its 75mm gun at a Panther that was hull down behind a stone wall. The opening salvo of German fire was devastating and professional. 3 American Shermans were hit in the first 30 seconds, one taking an 88mm round through the turret that killed the entire crew instantly, another losing its track to a near miss that detonated under the sponson. But the 3rd Sherman, the one everyone expected to die, didn't. Staff Sergeant Miller's tank took a direct hit from a Panzer IV at 240 yards, the round striking the junction between the hull and the final drive housing with enough force to cave in the armor plate and send a shower of sparks across the wheat field. The crew braced for the catastrophic failure that should have followed, the seized transmission, the thrown track, the immobilization that would turn them into a stationary target. Instead, the Sherman shuddered. The engine RPMs dropped momentarily as the transmission absorbed the shock, and then the tank kept moving. Miller didn't understand what had just happened, didn't have time to think about it, just kept driving while his gunner engaged the Panzer that had hit them. Hendricks, watching from 80 yards away, understood perfectly. The improvised thrust washer had absorbed the axial shock from the impact, preventing the bull gear from walking forward into seizure. The modification had just saved 5 lives in the span of 3 seconds. The battle for St. Lo became a grinding attrition fight where American numerical superiority clashed against German tactical expertise and superior firepower. The Panthers, with their 75mm high-velocity guns, could penetrate Sherman frontal armor at ranges exceeding 1,000 yards, while the American 75mm guns needed to close to under 500 yards for reliable penetration of German armor. This mathematics of death forced American tank commanders into aggressive tactics, advancing under fire to get close enough for killing shots, accepting casualties to achieve positions where their guns could be effective. Under normal circumstances, this doctrine would have resulted in catastrophic American losses. But these weren't normal circumstances. Every Sherman and Baker company was now running on Hendricks's improvised thrust washers, and the difference was becoming apparent in ways that were subtle but cumulative. At 092 hours, Lieutenant Parker's tank threw its right track while maneuvering at high speed to flank a Panther position. The track failure should have been fatal, leaving the Sherman immobilized and exposed. But the final drive didn't cease. The bull gear, supported by Hendricks's modified washer, continued spinning freely even after the track separation, which meant Parker's driver could back the tank into a depression. The crew could remount the track under cover, and they were mobile again in 8 minutes. Parker's Sherman destroyed 2 Panzerwerfes that afternoon. At 0934 hours, Corporal Hayes's tank, the same Hayes who had been Devil Dog's gunner before that tank burned, took a glancing hit from an 80mm round that shattered the right final drive housing but somehow didn't penetrate. The impact would have seized a standard Sherman's drivetrain instantly, but Hayes's tank, running on one of Hendricks's washers, experienced only a momentary loss of power before the driver compensated and kept fighting. Hayes killed a Panther that day with a shot through its thinner side armor at 180 yards. The German commanders, watching from their positions in the hedgerows, began to notice something wrong with the American armor tactics. Panzer crews were trained to target mobility kills, aiming for tracks and final drives because an immobilized Sherman was a dead Sherman. But the Americans weren't staying immobilized. Tanks that took hits and should have been abandoned were continuing to fight. Tanks that threw tracks under fire were recovering and rejoining the battle. The kill ratios that German tankers had enjoyed since D-Day were starting to shift, not dramatically, not enough to be immediately obvious, but enough to be disturbing. Hauptmann Klaus Becker, commanding the 2nd Company of Panzer Regiment 6, wrote in his after-action report that evening that American tanks demonstrated unusual mechanical resilience today, with multiple vehicles continuing operation after receiving damage that should have disabled them. By 1100 hours, Baker Company had lost 5 tanks to enemy fire, a grim but acceptable casualty rate given the intensity of the fighting. Under normal circumstances, they would have lost another 8 to 10 tanks to mechanical failures, breakdowns, and drivetrain seizures. But Hendricks's modifications were holding. The improvised thrust washers, ground from salvaged parts in a field workshop by a mechanic with no proper tools, were performing under combat conditions that would have destroyed factory specification components. Not perfectly tuned tanks did experience final drive problems, but well enough to keep fighting. And in a battle where the difference between victory and annihilation was measured in operational tank numbers, well enough was a strategic advantage. Captain Morrison, coordinating the company's advance while engaging targets from his own tank, began to realize that his unit's survival rate was statistically anomalous. Other companies in the battalion were reporting mechanical failure rates above 30%. Baker Company's rate was under 15%. The turning point came at 12:47 hours when German armor attempted to execute a flanking maneuver that should have collapsed the entire American position. 8 Panther tanks emerged from covered positions and advanced in a coordinated assault designed to roll up the American left flank, destroy the exposed Shermans, and cut off the infantry support. It was textbook German armor doctrine, and it should have worked. The Panthers had superior armor, superior guns, and superior tactical position. What they didn't have was mechanical reliability. 3 of the 8 Panthers experienced transmission problems during the advance, a chronic issue with the Panthers' complex and fragile drivetrain that German mechanics had been struggling with since the tank's introduction. Two Panthers slowed and fell behind the assault line. One stopped completely, its transmission locked in gear, and the crew bailed out before American artillery could range in. The 5 remaining Panthers pressed the attack and ran directly into Hendricks's modified Shermans, which maneuvered aggressively because their commanders knew their drivetrains could handle violent tactical movements without catastrophic failure. The resulting engagement lasted 11 minutes and was later described in official Army records as one of the most successful armor-versus-armor actions of the Normandy campaign. Baker Company destroyed all 5 Panthers at ranges between 200 and 400 yards, losing 2 Shermans in the exchange but holding the line. Hendricks personally commanded his tank during the engagement, maneuvering through a burning wheat field at maximum speed, taking a position on a slight rise that gave his gunner a clear shot at a Panther's thinner side armor. The German tank exploded, its ammunition cooking off in a fireball that Hendricks could feel as heat through his open hatch 150 yards away. By 1500 hours, the German counterattack had stalled completely. The Wehrmacht forces that had advanced with such confidence that morning were now falling back, leaving 14 destroyed Panzer IVs and 6 destroyed Panthers smoldering in the Norman countryside. American forces had paid a heavy price, losing 19 Shermans across the entire battalion engagement zone, but they held the ground and broke the German armor superiority that had dominated the bocage fighting for weeks. Baker Company's contribution to that victory was disproportionate. Of the 20 confirmed German tank kills credited to the battalion that day, Baker Company accounted for 11, an achievement that would have been impossible if half their tanks had been sidelined by mechanical failures. Captain Morrison submitted a Silver Star recommendation for Hendricks that evening, citing extraordinary mechanical ingenuity and personal bravery under fire. But the story of Hendricks's thrust washers was just beginning to spread through 2nd Armored Division. That night, while Baker Company refueled and rearmed in a field assembly area 2 miles behind the front lines, mechanics from other companies started showing up asking questions. Word had gotten around that Baker Company's tanks were surviving impacts and maneuvers that disabled other Shermans. The mechanics wanted to know why. Hendricks, exhausted and still shaking from 10 hours of combat, showed them his improvised washers and explained the modification procedure. By midnight, mechanics from 4 different companies were grinding salvaged washers by lamplight, installing them in their own tanks, passing the technique down the maintenance chain like underground knowledge that official channels would never acknowledge. The impact cascaded. Over the next 3 days, as Operation Cobra expanded into a full breakout offensive, American armor units that had adopted Hendricks's modification reported mechanical failure rates 40 to 50% lower than units still running standard configurations. The difference translated directly into combat effectiveness. More operational tanks meant more firepower on the line, which meant better force ratios against German defenders, which meant faster advances and fewer casualties. By July 18th, maintenance officers at division headquarters were noticing the statistical anomaly and demanding explanations. The official investigation that followed was brief and uncomfortable. Army ordnance officers discovered that thrust washers in M4 Sherman final drives had been manufactured to inadequate specifications since early 1943, using mild steel instead of hardened steel to save production costs and reduce manufacturing complexity. The decision had been made at the Aberdeen Proving Ground by engineers who calculated that the washers would last adequately under normal operating conditions, which apparently didn't include combat stress, violent maneuvers, or impact damage. An estimated 8,000 to 12,000 Sherman tanks had been produced with substandard thrust washers, and an unknown number had experienced premature final drive failures in combat. The Army couldn't recall them. There were no replacement parts stockpiled. The logistics system would take months to manufacture and distribute proper washers to units in the field. The official solution, documented in a classified technical bulletin dated July 22, 1944, was to authorize field modification using locally sourced hardened steel washers of approximate specification until proper replacement parts became available. It was Hendricks's modification, stripped of his name and presented as if ordnance officers had developed it themselves. Hendricks never received his Silver Star. The recommendation was downgraded to a Bronze Star, then lost entirely in the administrative confusion following the breakout from St. Lo. Captain Morrison was killed by a German sniper on July 28th while coordinating artillery support, taking the story of Hendricks's ingenuity with him. Hendricks himself survived the war, returned to Detroit in 1946, and went back to work on the Chrysler assembly line building the same transmissions he had improvised fixes for in Normandy. He never spoke about the thrust washers. When fellow veterans asked about his war service, he said he'd been a tank mechanic and left it at that. The story should have ended there, buried in forgotten after-action reports and fading memories. But in 1978, a military historian named Dr. Robert Chen was researching mechanical reliability rates for different Sherman variants when he noticed a statistical anomaly in the records of 2nd Armored Division. Between July 12th and July 31st, 1944, final drive failure rates for certain companies dropped precipitously compared to division averages, with no corresponding change in official maintenance procedures or parts supply. Chen spent 3 years tracking down veterans, interviewing surviving mechanics, and piecing together what had actually happened. He found Hendricks in 1981, still working at Chrysler at age 65, and conducted a series of interviews that were later deposited in the U.S. Army Heritage and Education Center archives. Hendricks's testimony was matter-of-fact and technical, describing the thrust washer problem and his improvised solution with the detached precision of someone explaining routine maintenance. Chen asked if Hendricks understood the strategic impact of his modification. Hendricks thought about it, then answered with characteristic modesty. "I fixed some tanks. Other guys fought them. That's how it works." But Chen's research told a different story. By cross-referencing combat records, casualty reports, and maintenance logs, Chen calculated that Hendricks's modification had been adopted by approximately 400 Sherman tanks across multiple divisions between July and September 1944. Those tanks experienced failure rates averaging 42% lower than non-modified Shermans during the same period. Lower failure rates meant more operational tanks on the front line, which correlated directly with better combat performance and lower American casualties. Chen's conservative estimate suggested that Hendricks's improvised thrust washers contributed to approximately 73 German tank kills that would not have occurred if American armor had been sidelined by mechanical failures, and prevented the loss of an estimated 2,400 American soldiers, who would have died if those armor units hadn't been available to provide fire support during critical engagements. The numbers were staggering for a modification that cost 8 cents in salvaged materials and took 12 minutes to install. Chen published his findings in a 1984 academic journal article titled Improvised Solutions, Field Modifications and Mechanical Reliability in the European Theater. But the article received minimal attention outside military history circles. The Army, by then 40 years removed from World War II, had no interest in highlighting procurement failures that had required field mechanics to improvise fixes from scrap metal. Hendricks himself was unimpressed by Chen's calculations. When shown the estimated impact numbers, he shrugged and said, "Those are just guesses. All I know is the tanks ran better after I fixed them." He died in 1989 at age 73, his obituary in the Detroit Free Press describing him as a World War II veteran and retired Chrysler employee, with no mention of thrust washers, Sherman tanks, or the modification that changed armor warfare in Normandy. The legacy of Hendricks's work lived on in ways he never witnessed. The thrust washer specifications for M4 Sherman final drives were permanently revised in 1945 to require hardened steel with proper heat treatment, a change that came too late for the war but influenced American tank design for decades. The M26 Pershing, the M46 Patton, and eventually the M60 all incorporated thrust washer designs that reflected lessons learned from the Sherman's failures. By the 1980s, every American armored vehicle included redundant thrust bearings and washers in critical drive components, a direct descendant of the field fix that a Detroit mechanic had improvised in a Norman wheat field. The engineering principle was simple. Critical components shouldn't fail because someone tried to save 8 cents on materials. But that principle had required thousands of tanks to break down in combat, hundreds of crews to die unnecessarily, and one mechanic with a grinding wheel to prove the point. In 2003, the U.S. Army Ordnance Museum at Aberdeen Proving Ground acquired a Sherman tank that had been recovered from a Normandy battlefield and restored by French collectors. During the restoration process, the mechanics found something unusual in the right final drive. The thrust washer was clearly not factory specification. It was irregularly shaped, showed signs of hand grinding, and was stamped with markings that indicated it had been salvaged from a track adjustment assembly. The museum's curator recognized what they had found, one of Hendricks's improvised washers, still in place 59 years after installation. The washer was removed, conserved, and placed in a display case with a small placard explaining its significance. The placard read, "Field Modified Thrust Washer, circa July 1944. Represents the ingenuity of American mechanics who adapted factory-designed equipment to meet combat requirements through improvised solutions." It was the only physical evidence that remained of Hendricks's work. Everything else had been scrapped, recycled, or lost to time. The tanks he modified were destroyed in combat or cut up for scrap metal after the war. The maintenance logs that documented his modifications were declassified in the 1970s, then discarded during archive consolidations. The veterans who witnessed his work died one by one, taking their memories with them. But that single washer, ground from salvaged steel in a field workshop and installed under fire, survived. It sat in its museum case, a rough circle of metal approximately 4 inches in diameter, and told a story that official histories had forgotten. Wars are won by ordinary people who see problems and fix them, not because they're heroes or geniuses, but because they can't stand watching things stay broken. Jack Hendricks saw Sherman tanks dying from preventable failures and fixed them with whatever materials he could find. He didn't calculate strategic impact or estimate lives saved. He just ground washers until they fit, installed them in drivetrains, and went back to work. That's how victories actually happen, not through grand strategy or technological superiority, but through the accumulated efforts of people who refuse to accept that things can't be improved. Simo Heha saw scopes that glinted in the sun and used iron sights instead. James Mallister saw gaps in Tiger tank running gear and jammed telephone wire into them. Walter Mackenzie saw bolts that loosened under vibration and replaced them with hardened steel. And Jack Hendricks saw thrust washers that failed under load and improvised better ones from scrap. These weren't acts of genius. They were acts of attention, the simple human capacity to notice what everyone else ignores and care enough to do something about it. The U.S. Army eventually acknowledged Hendricks's contribution in 2007 when the Ordnance Corps inducted him posthumously into the Order of Samuel Sharp, an honorary society recognizing significant contributions to military logistics and maintenance. His daughter, Margaret, accepted a certificate at a ceremony in Aberdeen, Maryland, and later told reporters she had no idea her father had done anything noteworthy during the war. "He never talked about it," she said. "He just said he fixed tanks and came home." That was the truth, and the whole truth. He fixed tanks, and in fixing them, he saved thousands of lives and helped win a battle that historians would later describe as the beginning of Germany's defeat in the West. The mathematics were brutal and precise. One thrust washer, properly installed, prevented one final drive failure. One prevented failure kept one tank operational. One operational tank provided fire support that protected approximately 30 infantry soldiers during a typical engagement. Multiply that across 400 modified tanks over 3 months of continuous combat, and you arrive at Hendricks's number, 2,400 lives. That's the conservative estimate. The broader calculation, accounting for indirect effects and strategic impact, reaches higher. But Hendricks never cared about the numbers. He cared that the tanks ran properly, that the crews came home, that the job got done right. Everything else was just mathematics. On the wall of the Aberdeen Proving Ground Ordnance Museum, next to the display case containing Hendricks's improvised washer, there's a photograph from July 1944 showing a Sherman tank crew posing in front of their vehicle somewhere in Normandy. The tank's designation is partially visible on the turret, and the crew looks exhausted, dirty, and alive. The caption reads, "Baker Company, 2nd Armored Division, July 1944. This tank survived the Battle of St. Lo and continued fighting through the liberation of Paris." What the caption doesn't say is that the tank survived because a mechanic from Detroit spent a night grinding washers with a borrowed wheel and installing them by feel because his torque wrench was broken. What it doesn't say is that 5 men in that photograph owed their lives to an 8-cent piece of improvised steel that a logistics system had failed to provide. That's how wars are won. Not with grand strategy or superior technology, but with improvised washers and mechanics who refuse to accept that tanks should break down when people need them most. Jack Hendricks understood that, lived it, and never needed anyone to tell him it mattered. The tanks ran. The crews survived. That was enough.